Hi, I'm Alex from the Zscaler Customer Success Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for the configuration of the Advanced Cloud Sandbox. This is part 1, Basic Considerations. Before we move on to discuss Sandbox policy, it's important to understand what's at stake in today's world. While you're likely aware of this by now, the cost of not stopping file-based attacks is severe. Ransomware as a service has emerged as a top cyber trend, placing the ability to build and launch file-based attacks within reach of many more, less sophisticated cybercriminals. Attacks are not slowing down, with the world seeing attacks every 2 seconds against consumers and businesses. And the cost of ransomware is considerable. One estimate puts the potential cost at more than $260 billion by 2031. While most organizations have some form of protection against malware, attackers constantly evolve malware variants to increase probabilities of a successful infection. This means they keep trying to slip in new threats that look exactly like benign files past defenses, making sandbox analysis critical in a security posture. On any given month, Zscaler will therefore analyze over 30 million new, unknown, unique files, resulting in an average of 30,000 new threats and suspicious files being detected and blocked for all Zscaler customers. Before we move on, let's briefly remind ourselves of the way that Zscaler's layered approach to threat detection and prevention works. When a user who is protected by Zscaler Internet Access browses the internet, their traffic goes through a number of security controls. The first of these is access control. Is the user allowed to access the destination or URL category for that destination? If yes, we move on to reputation-based blockings. Is the destination a known bad destination? If so, then it gets blocked. Next, we analyze the contents of the transactions using deep packet inspection. From this, we can compute a risk score for the page based on the elements on the page, the technologies involved, their destinations, and so forth and so on. You can then configure policies based on this risk score. For example, you could decide that if a page risk score is above a certain value, say 70, then the page should be redirected to a browser-isolated session. Finally, once we're past all of these controls, we move on to the file-based controls, such as file type controls, which function a lot like access control, but for files, i.e. is my user allowed to download this type of file or not? And finally, the sandbox behavioral analysis, where files are sent to the sandbox to be detonated and examined to determine whether they're benign or malicious if they're not already known. One thing that's important to understand is that without SSL inspection, there are very few of the security controls that can be applied to a transaction that is encrypted but not inspected. Of these, only access control and known bad destination blocking can be applied to encrypted but uninspected transactions. Keep in mind that 99% of all web traffic observed is encrypted today, so it's vitally important that you inspect your traffic before configuring your sandbox policy. To finish this video, let's take a look at a few statistics specific to file types. The first one of these is the top file types by percentage of malicious files. Here we can see the 6 file types that are most commonly malicious. Executables and DLLs, where 3.7% of all files sent to Sandbox were found to be malicious. Java archive files, where 0.17% of all files sent to Sandbox were found to be malicious. Zips and other compressed archive files, such as RAR or 7-zip, where 0.17% of files were found to be malicious. Office documents for Word and Excel, where 0.3% and 0.21% of files sent to Sandbox were found to be malicious, respectively. And finally, Android packages, or APKs, where a whopping 13.3% of files were found to be malicious. Finally, here's some data on the distribution of malware hidden in encrypted traffic across otherwise benign URL categories. Here we can see that corporate marketing, professional services, and the miscellaneous category contain over 75% of all malware that was hidden inside encrypted benign traffic. This is why it's important to understand that you should inspect all traffic and sandbox traffic for all destination URLs to make sure that you're catching hidden malware. That's it for this video. Thank you for watching.